Good morning, everyone. Welcome to Mechanical Engineering Graduate Program Info Session. This is Hideaki Tsutsui. I'm the host today. I'm Associate Professor and Graduate Advisor for the department. All right, let's wait for another minute before we start so that everyone can join, hopefully soon. So as you can see here, please use your full name to sign in so that we know who actually attended the session. I believe a UCR Graduate Division has promised a $30 discount on application fee. And so we need to know who actually attended the session. So you can change your name from the participants list if you are not showing your actual name. All right, so let's get started. Welcome again. All right, so yeah, let me just make a sort of housekeeping announcement. So once again, please use your full name to sign in. And this Zoom session is recorded and will be posted online for those who cannot join today. So please remember that. All right, so again, well, let me All right, so I think you can see my face. Good morning, everyone. My name is Hideaki Tsutsui from Mechanical Engineering Department. All right, so just to save bandwidth, as my son is taking Zoom school right now, so let me close my video to save the bandpass a little bit. All right, so here's today's agenda. So right now we're doing the welcome and check-in by myself, and I will quickly move on to the next section, program introduction. And after that, we have two faculty members from a program to share their research with you briefly. And we have students coming from Mechanical Engineering Graduate Student Association to share their life as a graduate students and their research. After that, we will hopefully have 10-15 minutes left for Q&A. All right, so please follow the rules below. Mute yourself when presenters are talking. And please use the Zoom's chat function to pose questions. And for questions very specific to yourself, something that involves your privacy, please wait until the Q&A section or use your user email instead. I will have my email address posted later, or I will probably post it on chat as well. Okay, so let's get started. But if you have any technical issues, again, please use the chat function to let us know. All right, so here's the program introduction. UCR Mechanical Engineering program is relatively new. We are only 20 years old. We have a total of 26 faculty members, 11 full professors, 4 associate professors, and 11 assistant professors. So compared to more historical or established programs where you see probably 20 or 30 full professors, only a handful of assistant professors, we have a lots of young professors, which is good because they bring new ideas and exciting research programs to our program. So if you happen to join a program, you will see that we have lots of active young professors doing fantastic work. We have about 100 graduate students, including both MS and PhD students. And as you can see in this chart, the red is the number of faculty members, and the blue is the number of graduate students. We keep increasing every year, and we are hoping to grow further, especially the size of students. All right, The fact that you are attending this info session is that you're interested in going to grad school. So that's great, but it's important that you ask yourself why you want to go to grad school, right? Here is the list of some reasons I picked up from this Northeastern University's graduate program website. So for example, graduate schools help you attain specialized knowledge. So during your undergraduate education, you studied mechanical engineering or other major broadly, right? In case of mechanical engineering, you studied solid mechanics, fluid mechanics, controls, material science. But in graduate school, you can focus your courses and research onto a particular field or two and build a competitive edge. Also, going to grad school helps you advance your career. Employers recognize your commitment to advanced knowledge and expertise. So I've talked to one of our board of advisors, and when he hires new employees, he appreciates, for example, master's graduates who has spent a year or two learning this specialized knowledge than a fresh bachelor graduate, because he knows that this master's graduate has dedicated more time and keen on learning new things. Also, going to grad school might increase your earning potential. Here's the median annual wages for mechanical engineers. Again, this is data from 2015, a study done by Georgetown University. According to this study, mechanical engineers with a bachelor's degree have an average of $87,000 versus mechanical engineers with graduate degrees have $107,000. So the difference is $20,000 every year, and it continues to grow. And again, the grad school helps you engage lifelong learning. So nowadays, technology and lots of things are evolving very quickly. So some technology new 10 years ago could be obsolete right now. So it's very important for you to be a successful engineer. To sustain your career, you need to engage lifelong learning. So a graduate program is a good place to start attaining the habit of keep learning. All right. And attending graduate school enhances professional network. So class size is smaller in graduate programs, so you have a lot closer connections to professors, especially when you're doing, let's say, master's or PhD research with a specific professor. And you get to interact with your fellow students as well. And graduate studies often provides opportunities to attend conferences to present your own work and meet fellow graduate students from other institutions and sometimes from foreign countries. So it's a good way of expanding your network. All right, so these are a couple reasons I wanted to share, but it's very important for you to ask yourself, what's your reason to go to grad school? All right, so here are sort of example of where our graduates went to work for after graduation from a program. So right now, our graduates are now professors at several institutions like UC Merced, our sister campus, Stony Brook University, University of Wyoming, and many campuses of CSU systems. And we have placed lots of our graduates into very famous and big corporations like Raytheon, Amgen, Intel, Boeing, to name a few. And many others are working at like startup companies and other companies not listed here. And other graduates are working at government agencies, U.S. Forest Service, California Air Resource Board, NAVC, SLAC, that's a National Accelerator Laboratory located in Stanford, and others are working at other national labs as well. So this is quite an impressive list for a program like us, just with 20 years of history. Right? Our graduates are very competitive already, and the quality continues to improve every year. So I have no doubt in 5 years, this list will become even more impressive. And I hope that you will be one of them. Okay. So once again, if you have any questions, please feel free to post your questions using a chat function. I will try to address them at the end of my presentation. If it's lengthy one or we have too many questions, then we will wait until a Q&A session at the end of this hour. Okay, so let's talk about programs. So for master's degree, we have two plans. One is exam plan, and the other one is thesis plan. So in exam plan, student enters a program and spend a year. It's typically 3 quarters, or sometimes 1 additional quarter, but basically take courses, graduate level courses, and study hard and pass all the courses. And at the end of the year, usually in June, students will take an exit exam. These are the written exams based on some of the courses students already took during the year. And when the student passes all the exams, they can graduate with master's degree in mechanical engineering. And the other plan, thesis plan, it's a little bit different. So the students will take a similar courses, graduate level. And after a year, they probably switch to more research, start engaging in research activities with guidance of a research advisor, and produce some results and write a thesis and make defend his or her research and then graduate. So you can see that it could take additional year, but I have seen that a student who has done coursework and research simultaneously and then finish this thesis plan in 1 year. So, but if you're interested in thesis plan, I think it's safe to assume that it would take more than a year, perhaps year and 1 quarter to 2 years. But for both exam plan and thesis plan, the normative time for graduation is 2 years. But for the exam plan, lots of our students graduate after a year. Okay. So for PhD degree, it's a lot longer. Typically, PhD study takes 5 years, a little more. So in PhD program, students do the similar coursework in year 1, and then they take the written exam called a preliminary exam at the end of the year. So this exam is similar to the exit exam, comprehensive exam for the master's exam plan, and based on the coursework. So once he or she passes this preliminary exam, usually engage more on research and do research for another year or 2. And then when the student and his or her research advisor think that a student is ready for qualifying exam, the student writes a 15-page research proposals summarizing their preliminary research work and the future plan, and then present that research proposal in front of a committee of 5 professors. And when student successfully passes this exam, students switches from PhD student to PhD candidate. Right? After a student becomes a PhD candidate, usually conduct additional 1 to 3 years of research, published work, and write a thesis and defend your PhD thesis or dissertation. And when you pass this defense, which is an oral exam, you graduate and become a doctor. All right. So since PhD study is long, as I said, it takes 5 years or probably more. PhD students usually have opportunities to do other activities such as teaching assistant. So you work with a formal course instructor to teach undergraduate courses, and you go to conferences to present your research work. All right. Okay, so doing research requires a good advisor. So I didn't say this in the previous 2 slides, but these sort of cartoons are adapted from phdcomics.com. If you join graduate program, you will probably check this website and see comics about the life of PhD students. Also, they do have 2 full feature movies as well. But this chart shows the analogy between marriage and PhD. So I certainly hope that the marriage lasts longer than typical 7.5 years. And I also hope that the PhD study lasts a little bit shorter. So our departmental average is about 5.5 years, but some students can finish in 4 years as well. All right. So, but the bottom line here is that it's very important that you find a good mentor who does research that interests you. Okay, so you're not gonna go into many years of commitment with somebody with a not a good match. So it's very important for you to find an advisor who is a good match for you in terms of research interest and personality as well. So you need to do your homework before signing up. So my suggestion here is that you go to departmental website, and we have a list of all the mechanical engineering faculty members. And from there, you can check what their specialties are, what kind of research they're working on, what their ranks are. And also many professors have their own research websites. This is mine. So as you can see in this tab, you can look up like current members, research topics, list of publications, some photos. So it's different from a professor to a professor, but many of the professors have like research topics and lab members and publications. So you can learn more about the individual labs. Okay. And also at some point, you might want to reach out to the students as well, right? So because again, you'll be committing 4, 5, 6 years of your 20s or 30s or 40s, depending on your age right now. And you would want to join the lab, which is very collegial and helping each other, and might have some fun events. So I suggest that you reach out to 1 or 2 of the lab members in the lab you're interested in to find out their culture. Okay. So, but sometimes professors too busy and they don't update the list of publications on their website. If that's the case, go and check Google Scholar for latest publications. This is the Google Scholar page and screenshot of my colleague, Professor Lorenzo Mangolini. This is a little bit old, so that's why we don't see 2020 publications. But if you check his name on Google Scholar, and you will see latest publications, then you will see right away that what kind of research topics his group is working on. And if you're interested, you can click and download papers and dig much deeper and very specific. I mean, doing so would probably impress Professor Mangolini if you approach him asking him if there's a position for you to join his group, right? So when you find your faculty members of interest, send them emails, schedule phone calls, or nowadays Zoom meetings, and do a lab visit, possibly the virtual lab visit some professors might be willing to offer. But it's a competitive process. Some of the professors are getting inquiries every day from all over the world. So it's important that you get detected by the professor's radar if you really want to join a specific lab. Okay, so don't wait until it's too late. So now is a good time to start. All right, so next topic I want to cover is the financial support for graduate study. So PhD students are typically fully funded, which means that first year of PhD study is covered by Central Fellowship coming from UCR's graduate division. So it covers both fees and stipend. And the department furnishes 1/4 of teaching assistantship, also covers the fees and stipend. And beyond that, so beyond this 4 quarters period, PhD students are typically funded by research advisors, research grants until your graduation. Okay, and the students need to publish to graduate, and the advisors need to publish to secure research grants. So I sort of emphasize this because typical research grants from federal agencies are just 2 or 3 years period. So that means it's not enough to sustain or to cover 5 years of PhD research. So it's very important for the students to keep producing the data and publishing so that they and their research advisors can go after additional research grants to support your funding and to expand the research program, right? And in case of MS students, they are typically self-supported, but although it's not very common, MS students can be appointed as TA and GSR graduate student researcher, research assistant. So sometimes we find that we cannot find the teaching assistant for some courses, and we rely on, if we find a good match in MS students, the TA position goes to them. And some professors cannot find a good match for their research project, and they might be open for hiring a master's student as a GSR as well. So it's possible. Okay, and then also quite a few MS students continue on as PhD students and become eligible for the financial package. So PhD study is like 5 years of commitment. So many of you might not be sure, you're interested in research, but not sure whether you want to spend 5 years, and you're not sure whether you want to become a professor or your career goal requires a PhD degree. Then you might want to start off as an MS student and engage with research. And if you do well, and if you want to continue on, you can talk to your research advisor and then plan to continue on as a PhD student. If that happens, you get the same fellowship and financial aid from the university and department and your advisor. Okay. All right, so for the admission requirements and application process, the detailed information is available here. So you can go to our website and look graduate program tab, and you should be able to find them. Okay, so the minimum requirements are undergraduate GPA of 3.0 or higher. And for PhD applicants only, we require a GRE test score of 300 or higher. But for master's students, GREs are not required. This is something new starting this year. The entire UCR campus is moving toward doing away with GRE, and our program is removing GRE requirement for the MS program. Okay, so here is the asterisk. So although these are stated minimum requirements, but we still want to encourage you to apply even if your GPA or GRE are slightly lower than the requirements. So if your GPA is 2.85, 2.9, don't hesitate and just go ahead and apply. We have admitted lots of applicants with 2.8 GPA, 2.9 GPA, right? You might want to justify why your GPAs are slightly lower, and also you want to talk to professors and get a very strong letter of support, and that shouldn't be a problem to get in. Okay, so the application package includes your transcripts, GRE score if you're applying for PhD program. If you're international students, you need a TOEFL or IELTS score for English proficiency, and you need to submit statement of purpose and personal history statement and 3 letters of recommendation. Okay. So let me wrap up quickly. So later today, we have a representative from Mechanical Engineering Graduate Student Association talking about their experience as a graduate student. But they throw lots of social and networking fun events. Pre-COVID time, we had a quarterly barbecue hosted by them, sponsored by the department. They organize a very good annual research symposia for graduate students to present. And they sometimes organize a field trip to visit some interesting venues in Southern California as well. So we do have lots of social networking opportunity as graduate students as well. All right, so this slide might not be applicable for those of you who are already a senior or have graduated and going to apply this fall. But if you happen to be a junior or sophomore right now, UCR offers lots of undergraduate research opportunities. You can look up some of the programs from this link. And one thing I wanted to mention is this mentoring summer research internship program. This is for non-UCR students, I believe, but it's an 8-week program during the summer. Graduate school, it offers a grad school preparation workshops and social activities, and stipends and room and board are available to attendees. So it's a good way to test whether you like research or whether you enjoy UCR. So if you still have time, please consider this. And application deadline is typically in late February to early March. This past summer, we unfortunately had to cancel it because of COVID, but I hope that it will be resumed this coming summer. All right, with that, I'd like to thank you for your attention, and we're happy to answer your questions. So this is me, Hideaki Tsutsui. So please feel free to send me questions. All right, before I move on to next speaker, Professor Jun Shen. Okay, well, I think I had a question, but it's a private one, so I will answer through chat. Okay, so please send your questions via chat so that we can answer. All right, so let me stop sharing, and Jun, it's your turn.
Hi everyone, my name is Jun Shen. I'm assistant professor in mechanical engineering. Thanks for the opportunity to talk about my research here. So my research is focused on robotics with applications in medical and surgical systems. So my lab is called RAMS Lab. So we are working on several research areas, including imaging-guided surgical robots, medical devices, rehabilitation robots, and we're also creating some smart actuation and sensing systems for this kind of robotic systems. So here is a list of our ongoing projects. As you can see, we're working on some CT-guided steerable robots for tissue biopsy, and we are also working on the MR-compatible neurosurgical robots. And we're also developing soft and wearable devices for different applications, such as health monitoring and rehabilitation, and also cardiovascular procedures. And my research is highly interdisciplinary. So we are collaborating with experts in different areas. For example, we are collaborating with colleagues in ME, EE, CS, BioE, and also School of Medicine. And definitely, we're also collaborating with people, with doctors in hospitals. So I would like to talk about the first project, which is about the neurosurgical robots. As you can see, a lot of neuro disease require interventional procedures, such as the intracerebral hemorrhage, ICH, brain tumor, and the pituitary gland tumor. So traditionally, the surgeons use endoscopic neurosurgery to solve these problems. They insert some straight endoscopic tools, either through a small keyhole on the skull or through the nose, to reach the targets and remove those tumor or the cancer tissue. However, because of the irregular shape of these targets, and sometimes their locations are quite tricky, it's very difficult to completely remove them. So we want to have some more flexible and dexterous tools. So for the ICH problem, we create a robot called the niche robot. So same as other tools, it can be translated in axial direction, but it also has a very flexible tip, and it can be bent, and it can also be rotated. So in this case, we can reach any position in this kind of blood clot. And to create this kind of interesting motion, we use a technique called shape memory alloy. As you can see here, this kind of spatial alloy can recover its shape when we change its temperature. So we integrate this kind of material into the robot structure and create this kind of flexible motion in the robot. And we tested the whole system under CT and MR imaging guidance. And we can clearly see how the robot moves against the brain structures in the CT and MR. And the whole system can potentially be integrated with the current workflow of the minimally invasive procedures. So the last project I want to talk about is the steerable biopsy needle. So currently, the surgeons use a tool called biopsy gun to do the tissue biopsy, but this procedure is quite brutal. And sometimes this straight needle may miss the targets, and if it punctures through a blood vessel, it will cause a lot of bleeding. So we want to improve the safety and the precision in the tissue biopsy, and we'll create this kind of steerable needle. Basically, it consists of two tubes, and the inner tube can be deflected using tendon wires. Now the challenge is how to create this kind of small tendon-driven needle, right? So fortunately, we have a very good machine shop, and our machine shop use this kind of YEDM machine and creates a lot of slots along the tube, so we can have a flexible tube. As you can see, the diameter of this tube is only about 0.7 millimeter. So it's even smaller than the current biopsy gun. And by using the tendon wires, we can easily deflect the robot, as you can see in this simple demonstration. So these two projects represent our current work. But meanwhile, there are a lot of other interesting projects going on. So if you have any interest, please feel free to contact me after the sessions. Thank you.
Great, thank you, Jun. All right, so in interest of time, let's move on, and Professor Shan will stick around through the Q&A. So if you have specific questions, you can ask them. So next up is Professor Nozari. Go ahead, thank you.
Good morning, everyone. My name is Erfan Nozeri. I'm an incoming assistant professor, starting this year in the mechanical engineering department here at UCR. I hope you're all doing well. And if you've joined UCR, have a great time here. So I'm gonna be talking like John about my research, both to just give you a sense of the kind of things that we do in the department, and also to see if you're interested, and feel free to contact me if you are. So also similar to Jun, I'm doing basically using the tools and techniques in mechanical engineering for applications in biology, specifically for neuroscience and brain dynamics. And all right. The big picture idea is to try to make some advancements for the many problems in neurology and psychiatry that have remained outstanding over the past many decades. So you may know that a lot of the treatments that we have for neurological and psychiatric disorders are decades old. Some of them go back to the 1950s. And there hasn't been a fundamental advancement in many of those, even though they are like more safe these days and so on. But fundamentally, some of the drugs are discovered decades ago, and that is simply not enough in terms of the burden that it puts on the society. And this outstanding nature of these problems is why now there is the need and the demand for engineering, for math, for physics, for all science and engineering to bring in new tools and techniques and try to basically crack these problems and make advancements. And the tools that in my group we are trying to bring into this problem, because the brain is at the end of the day a dynamical system, is tools from systems and controls. You might have had courses in your undergrad, in your, if you had a master's before in control theory, and that's essentially built on the idea that you look at things as systems that basically get some input and transform them to some outputs. Very, very simple. That system might be a driving car, which is something that you might have seen in your coursework, but it could be anything pretty much. It could be a bacteria, or it could be the brain for us. So in the case of the brain, the inputs to the brain would be your senses, but also artificial ways of stimulating the brain using drugs, using magnetic fields, electric fields, so on, all the kind of treatments and technologies that we have these days, and the outputs are could be your mood, could be your movements, anything that the brain produces. And the end goal of control is to design the inputs, so try to use the ways that we can manipulate the brain and impact the brain in order to fix the outputs if they're doing something wrong, or even understand how this input-output system works. So I leave you with this, which is essentially the kind of three thrusts or pillars of systems and controls in general, but now we are applying it to the brain. We always have an identification direction of research, which is essentially building models, mathematical models for the brain. You get data from the brain using various different neuroimaging techniques, and then you put them into system ID, or these days people like to call it machine learning, to build essentially neural networks that match the activity of the brain. And then we use these models as well as more data from the brain to understand how the brain works, like analyze how the brain works and try to discover its mechanisms of action. How does it encode information? How does it process information? How does it translate information? and so on. And then we put all these models and analysis understanding together for the end goal, which is control, as I said. So how we can design the inputs to steer the outputs to normal function, let's say. Yeah, I stop here. Thank you very much. I'm going to be hanging around for the Q&A. Have a great rest of your day.
Right. Thank you so much, Arfan. Right, let's move on. So we now have, I believe it's Sanika from MEGSA to share her story. Morning, Sanika. Thanks for joining us.
Good morning, Professor. I hope my screen is visible.
Yes. You might want to speak up a little bit.
Okay. Is that good?
Yes.
All right. So my name is Sanika, and I'm a third-year PhD student, and I'm also currently like MEGSA Vice President. A brief about MEGSA first. We are the Graduate Student Association of the Mechanical Department, and we organize activities like there are annual symposiums, there are coffee socials, and like short trips for like all the graduate students. Like we went to Jet Propulsion Laboratory, like I guess last year. Moving forward with like my personal journey as a graduate student, I started working in like HVAC industry as an application engineer immediately after my undergrad. And a few months into my work, I realized that as a fresher, it wouldn't really give me a lot of flexibility, and I wanted to learn more in the field. So at that time, I decided to join graduate school, but I wasn't really ready to commit for like 4 to 5 years. And also, like, although I worked as an undergrad under various like graduate students, it was mostly like task based, and I didn't really do my own research. So I wasn't like very confident that I could do research like individually. So which is why I decided to join like the master's program in UCR. And I met graduate students at that time at a networking event who introduced me to his advisor, which is how I ended up working in one of the labs at UCR as a master's student. And this is just like my research. After 1 year of working into the lab, I realized that maybe this is what I want to do. And I was more confident in doing my own research, asking like scientific questions, answering them. So that's how I decided to like convert to PhD under the same professor. So right now I'm doing my PhD, and I'm mostly working in like applications of fluid dynamics, and a few projects of my research are indoor air quality modeling. As you can see, these are like a car interior and a room where we simulate the smoke spread or particle spread inside of the rooms. One of the other projects is outdoor air quality modeling, where we took up a city from Mexico and we modeled it in a software, and then we checked the concentration spread inside of the entire city to give basically like policy questions on how much concentrations are acceptable. And finally, we also work in like wildfire behavior, so mostly like transition from bushfires to like really uncontrollable like wildfires. And this is just the experimental setup and one of our test experiments. I'd like to like end my talk by thanking Dr. Tsutsui for letting me share my story, my previous and current advisors, and my lab mates and my undergraduates. I'm sorry, I think I ended. And the collaborators. So thank you. That's about it.
All right. Thank you so much, Sanika.
How do I stop sharing? Thank you, Professor.
Okay, great. Thank you, everyone. So now is the time for Q&A. So please feel free to either you can pause your question via chat, or now is a good time to voice your question. So you can use the Zoom to raise your hand, then I would pick your name, All right, don't. All right, if there's no question, what I want you to do is I would like you to introduce yourself. I see that some of you are from UCR, currently undergraduate, and some of you might be from outside of UCR. So if you don't mind, okay, I've been chatting with Ryan. If you don't mind, can you introduce yourself?
Oh, yeah, I'm Ryan Doling. I'm a transfer student at UCR. I'm a mechanical engineering major, and I am interested in the BS and MS program they offer.
Okay, thank you, Ryan. All right. Also, I've been chatting with Ansel. If you're around, can you introduce yourself too?
My name's Ansel. I'm also a transfer student in UCR, mechanical engineering major. I guess I graduate at the end of winter, and I was also interested in doing the BSMS program.
Okay, so you'll be finishing in winter and you want to
Yes.
start BSMS in spring.
Oh, sorry, no, in fall.
Oh, so when would you graduate?
I'll graduate at the end of winter and see if I can do the BSMS program in fall, if possible.
Okay, so why not during the spring?
Oh, I didn't even know that was an option.
Okay. Yeah, you might want to talk to Tara Brown, I think.
Okay.
Yeah, because you're kind of off cycle in a way. But I think, yeah, it's feasible. But I think since you're finishing in just 2 quarters, I think now is the time to find out what's needed and what options are available.
Okay. I'll see if I could shoot her an email then.
Okay.
Thank you.
All right, great. Thank you. So you know what's coming. So if you don't mind, Alex Bayer, thanks for joining. Can you introduce yourself?
Hey, so I'm Alex Bayer. I'm from the University of Delaware right now, and I'm a senior there. I'm just looking to apply here for a PhD program.
Okay, you're from University of Delaware?
Yeah, opposite
Oh.
side of the country.
Oh, okay, oh, great. Oh, thanks for joining. How did you find out?
So I signed up through that engine program, and I got a number of
Okay.
emails, and figured I'd stop by.
Oh, great. Thank you so much for joining us. So you're senior and applying for graduate programs this fall.
Yes.
Okay. All right, great. So again, yeah, if you find somebody, or if you have any questions, please send me an email, and I highly encourage you to look into individual professors' research.
Of course. Actually, I think I've looked at Dr. Nazari's work a little bit already.
Okay,
Do you guys do a lab rotation program for PhD students?
that's a great question. So the quick answer is no.
Gotcha.
So our program, basically we do the matchmaking at the time of application. So it's both ways. Some students reach out to professors, around this time or later in the fall, and have Zoom meetings and communicate, and then both students and professor mutually agree that a student will join his or her research lab if a student accepts offer from UCR. I mean, it's not a binding contract that the student cannot go to other institutions, but in case a student joins UCR, he or she is expected to join that professor's lab.
Gotcha.
Okay.
Right. Thank you.
All right. Okay. All right. Next, let me ask Cameron Hernandez. If you don't mind, can you introduce yourself?
Definitely. Yeah, I am a senior, an undergraduate at Brigham Young University in Utah. And I'm studying mechanical engineering and just interested in applying for a PhD program at the end of the semester. And yeah, I received an email as well about this event and thought it would be good to learn about what UCR has to offer.
All right, great. So you are also on the engine list.
I think so. I'm not exactly sure how I got the email.
Okay. Yeah, maybe
But-
it may be possible that our department chair sent out an email to your department chair and it was advertised that way. Okay. Oh, great. So what's your interest?
I am more interested in the applying mechanical engineering into biology and medical efforts. So yeah, there's been a lot that's been done there recently, and I think it's a very fascinating field.
Yeah, absolutely. Yeah, we have some of two of the speakers today applying engineering to biology. I work on biosensors and tissue engineering. We have a couple more professors doing bio applications as well. So yeah, I encourage you to look up professor's website and reach out to them if you're really interested in joining their labs.
Will do. Thank you.
Okay, thank you, Cameron. All right, so okay, I see Rebecca. Could you introduce yourself?
Yeah, hello. I'm Rebecca. I'm also a senior student at UCR right now, and I'm interested in the BSMS program.
Okay, great. Thank you. So you're graduating in June?
Yeah.
Okay, so you're not off cycle. All right, I think that's all. We had one more attendees, but I think he left. All right, so now I think you warmed up a little bit. So please feel free to throw questions. I think the questions about like BSMS and lab rotations, these are all excellent. So usually, if you don't understand something, it's likely that your fellow attendees don't understand that as well. So feel free to ask questions.
You said to contact Tara Brown regarding the BSN-MS program?
Yes.
Thank you.
So I believe Tara so this is only for current UCR undergrads, but we do have a 5-year BS plus MS combined program. And usually around this time, Tara will send out inquiries to like seniors and juniors who are eligible for BS plus MS to see if they are interested in pursuing that MS portion or not. So if you already receive an email, please reply. If you haven't, I think she's the person to talk to. Okay.
Professor?
Yes.
I had a question about, I guess, doing the teacher's assisting or being a TA during the BSMS program. Is that an option to do that?
So what happens about a teaching assistantship is that maybe a month before each quarter begins, staff, it's Paul Talaber from our department, send out an email to all the graduate students if you be interested in applying for TA positions. And then once everyone applies, and he and the graduate advisor, Professor Mangolini, basically selects the TA for each undergraduate courses. So MS students can still apply, but there's no guarantee that you get it. So lots of financial aids are prioritizing PhD students. So that's the case, but in the past, every year, I would say at least a few MS students receive TA appointments. So, you know, partially paid fees and tuitions, and sometimes they get
Okay.
for a quarter, right?
If
so
it's a,
yes.
I don't know if it's like too specific of a question, but would you recommend being a TA if one was to do the BSMS program?
I mean, if you need the financial resources, it's not a bad idea, right? But if you're busy taking courses, you know, you take 3 courses a quarter and then you're too overwhelmed, then I wouldn't recommend. But if you find that the courses are, you know, relatively easy after a quarter or 2, then I think it's fine to try doing TA. So
Okay.
there are two appointments for teaching assistants, like 25% appointments or 50% appointments. And 25% appointments expects the TAs to spend 10 hours a week on average, and 50% TA spends 20 hours a week on average. So doing TA would take that much of time away from you studying for MS program.
Okay. Thank you.
All right. All right, we have a couple more minutes left. Again, these are all great questions. Let us know if you have any questions like that or other kinds of questions. Are welcome as well. Okay, so let me repeat the question from Alex. I think I answered before, but this was a question. Does UCR do a lab rotation program for PhD students? The internet connection was not great, so let me answer again. So the mechanical engineering program does not do a lab rotation for PhD students. So we do a matchmaking at the time of application and admission, typically starting around this time through February, sometimes March. So it's very important that you contact professors of your interest and make an appointment. Okay, but other programs, I know that the bioengineering, what they do is they recruit a batch of PhD students, and everyone needs to do short lab rotations with 3 or 4 research labs in the first 2 quarters. So there are pros and cons. The mechanical engineering way would get you started on your research project right away. Bioengineering way, it gives time for both professors and students to find a good match, but you won't be able to start your main research until the 3rd quarter. So that could be a disadvantage. Okay, so it's almost 11, so I stop here. So I thank all the guest speakers. You may leave now, and I'm happy to stick around for another 5 minutes, 10 minutes if you happen to have questions. So let me know if that's the case. Okay, thank you so much again for attending our info session. I hope you're interested in our program, and I hope to see your applications in coming weeks and months. Right, thank you.